Next one, right? Advanced level question, sir. Advanced level question. Listen carefully. Find the number of positive integral solutions for the equation ABC equivalent to 18. ABC equivalent to 18. Method 1, which is the traditional method. Method 1, which is the traditional method. Traditional method. Traditional method. Please remember, variables are present in the question. If the variables are present in the question, what am I doing? I am doing ordered pair. I am doing ordered pair. If the variables are not present in the question, I will use unordered pair. That also we will discuss. If the variables are not present in the question, then I will use unordered pair. Method number 1. Traditional method. Students will solve like this. 1 into 18 is 18. 3 numbers can arrange among themselves in 3 factorial. 1 2 times it is there by 2 factorial. 3 factorial by 2 factorial, it is 3. 1 comma 2 comma 9. 3 numbers can arrange among themselves in 3 factorial, which is 6 ways. Next one, 1 comma 3 comma 6. 3 numbers can arrange among themselves in 3 factorial, which is again 6 ways. Next one, 2 comma 3 comma 3. 9 2s are 18. 3 factorial by 2 factorial, it is 3. So total, how many are there? Total 18 positive integral solutions are there for this equation. Why I stopped it? All the factors of 18 are over. 1 over, 2 over, 3 over, 6 over, 9 over, 18 over. 1 over 2, 3, 6, 9, 18. This method is not the best method, because for 18 you are able to write down the factors. What if right hand side is 180? 180 is 30, 2 square into 3 square into 5 power 1. Total 18 factors I will get. As the right hand side value increases, finding out by using traditional method is very time consuming method. This will take a lot of time. Very time consuming method. It takes a lot of time. Very time consuming. Right? So it's a very time consuming method, traditional method. I hope it is clear. This method we will not use in our exams. This method will not use, because as the right hand side value increases, this method will take a lot of time. Anything that we do, we should optimize the number of steps. This is method number 1. Method number 2, Anil Nair's way of solving. Method number 2. Listen carefully. Method number 2, Anil Nair's way of solving the question. Anil Nair's way of solving. How to solve it? Let us see. First, listen carefully, sir. First problem. ABC is nothing but 18. First, write down 18 as a power of prime bases. 3 square into 2 power 1. 3 square into 2 power 1. Now, if you observe closely, these 3 square, if I want to arrange on ABC, can I arrange it in one way like this? 3 power 0, 3 power 0, 3 power 2. Can I arrange it like this? Can I also arrange it like this? Yes or no? 3 power 1 into 3 power 1 is 3 power 2. Are you all with me? Right? That means if you observe, let the powers of ABC, let me call it as XYZ. Let the powers of ABC, let me call it as XYZ. Now, first thing, if you observe, the sum of the powers 0 plus 0 plus 2, it should be equivalent to 2. Can I say that sum of the powers x plus y plus z, it should be equivalent to the first power of prime base, which is 2. Here also, if you see, sum of the powers, it is equivalent to 2. Are the powers taking 0? Yes. X is greater than or equivalent to 0. y is greater than or equivalent to 0, z is greater than or equivalent to 0, 0, 0, 0, so add 3, 2 plus 3 is nothing but 5, 5 is nothing but 4c2, 4c2 total how many ways we got? 6 ways we got. How many ways we got? 6. Here also we got 6 ways. 3 numbers, 3 factorial, 2 are identical. 3 factorial by 2 factorial 3. 3 factorial by 2 factorial, it is also 3. You don't need to write that 6 cases. I hope it is clear. 2 over, next it is nothing but power 1. How can you arrange power 1? You can arrange it as 2 power 0, 2 power 0, 2 power 1. Sum of the powers should be equivalent to 1. Sum of the powers should be equivalent to 1. 0, 0, 0. 1 plus 3, 4. 4 is nothing but 3c2. Answer is nothing but directly 4c2 into 3c2. 4c2 is 6. 6 into 3, which is nothing but 18. 6 into 3, it is nothing but 18. Beautifully, by using integral solutions, you can solve the problem. First, write down this key point. Number of positive integral solutions. Number of positive integral solutions for ABC. Number of positive integral solutions for ABC, it is nothing but a number of non-negative integral solutions. Number of non-negative integral solutions. Non-negative integral solution for the powers of ABC. Please write down this point. Number of non-negative integral solutions for the powers of ABC. Instead of working with ABC, work with the powers of ABC. Work with the powers of ABC. See, if you observe again, second time I am explaining, 3 power 2 can be distributed on ABC. 3 power 0, 3 power 0, 3 power 2. ABC powers, if I call it as XYZ, powers can also take 0. And the sum of the powers is x plus y plus z is 2. X plus y plus z is 2. X is greater than or equivalent to 0, y is 0, z is 0. Add 1, 1, 1. 2 plus 3, it is 5. 5 is nothing but 4 gaps are there, so it is 4c2. Similarly, arrange the next powers. Similarly, arrange the next powers. Within few minutes, you will do these toughest problems very, very quickly, sir. You will do these toughest problems quickly. Please make a note of this point. Number of positive integral solutions for ABC, it is nothing but number of non-negative integral solutions for the powers of ABC. For the powers of ABC. Now, one more example I will do. ABC is nothing but 100. ABC is nothing but 100. 100 is nothing but 2 square into 5 square. Let the powers of ABC is XYZ. X plus Y plus Z is 2. X is 0, Y is 0 and Z is 0. So, these 2 plus 3, 5. 5 it is nothing but 4c2. Again the power is same. So, again 4c2. 4c2 into 4c2. 6 into 6. Answer is nothing but 36. Within 10 seconds you will get this answer. If you go by the traditional method, it will take, depending upon the right hand side value, that much factors you have to write down, which is a very complex method. Everybody kindly reply if the idea it is clear. 2 square into 5 square. X plus y plus z is 2. X0, y0, z0. 2 plus 3, it is 5. 5 will be 4c2. Here also it is same. So, it is also 4c2. 6 into 6 is nothing but 36. 6 into 6 is nothing but 36. Another example. If ABC is 180. If ABC is 180. 180 it is nothing but 36 into 5. 2 square into 3 square into 5 power 1. What will be the answer? X plus y plus z. It is nothing but either 2 or 2 or 1. XYZ greater than or equivalent to 0. Greater than or equivalent to 0 means add 3, add 3, add 3. 2 plus 3 is 5. 5 means 4C2. Again 2 plus 3, 5, 4C2. 1 plus 3, 4, 3C2. Direct answer. 6. This is exactly the reason why you should not miss any of the classes, sir. 36 3s are 108. Answer for the number of positive integral solutions for this one is nothing but 108. Still you can save time, sir, by writing like this. Power is 2. How many variables are there? 3. 2 plus 3 is 5. Answer is nothing but 4C2. Power is 2. How many variables are there? 3 variables are there. 2 plus 3, 5. Again 4C2. 1 plus 3 is nothing but 4. 4 is nothing but 3C2. 4C2 into 4C2 into 3C2. Answer over. 4C2. Directly you will get the answer. Some more examples. ABCD equivalent to 2 power 4 into 3 square into 5 cube into 7 power 5. Directly tell me the answer. Please stop using your pen. This question does not even deserve using pen for writing steps. 4 plus 4, 8. 8 is nothing but 7C3. 2 plus 4, 6. It is nothing but 5C3. 3 plus 4, 7. 7 is nothing but 6C3. 5 plus 4, 9. 9 is nothing but 8C3. Idea is clear, right, sir? I hope the idea it is clear. Suppose A1, A2, A3, A4, A5. It is nothing but 2 power 100. 2 power 100. Please tell me the answer. 100 plus 5 variables. 105. Answer is nothing but 104C4. 104C4. This is how you determine the number of positive integral solutions for the equation. Everybody kindly reply if the shortcut is clear to you. 4 plus 4, 8, 7C3. 2 plus 4, 6, 5C3. 3 plus 4, 7, 6C3. 5 plus 4, 9, it is 8C3. Everybody kindly reply if this logic is perfectly clear to you. If this logic is perfectly clear to you. Reply, sir, everybody, right? Idea is to teach you as many shortcuts as possible. 100C4. One more question. Suppose if the question is ABC equivalent to K. ABC equivalent to K. K is a factor of 144. K is a factor of 144. Positive integral solutions. Any factor of 144 can be written as 144 by D. D is greater than or equivalent to 0. So, this is nothing but ABCD equivalent to 144. 2 power 4 into 3 square. 4 plus 4, 8. 8 is nothing but 7C3. 2 plus 4, 6. 6 is nothing but 5C3. 7C3 into 5C3. 7C3 into 5C3. I hope the idea it is clear. The question can also be asked like this. ABC equivalent to K. K is a factor of 144. One more question. ABC is equivalent to K. K is nothing but a factor of 360. K is nothing but a factor of 360. So, any factor of 360 is nothing but 360 by D. 360 by D. It is D greater than or equivalent to 1. D greater than or equivalent to 1. So, ABCD. ABCD it is nothing but 2 cube into 3 square into 5 power 1. 3 plus 4, 7. 7 is 6C3. 2 plus 4, 6. 6 is nothing but 5C3. 1 plus 4, 5, which is nothing but 4C3. Direct answer you will get it. 7C3 into 5C3 or 6C3. This is D greater than or equivalent to 1. Any, please write down, sir. Any factor for n. Any factor for n. This can be written as n by x. X is greater than or equivalent to 1. Any factor. So, ABC is 144 by D. D greater than or equivalent to 1. Here K is a factor of 360. 360 by D. 360 by D. I hope the idea it is clear. Next one. Now we will solve, I think, find the number of positive integral solution. 360 is 2 cube into 3 square into 5 power 1. 3 plus 3 6. 6 is nothing but 5c2. 2 plus 3 5, which is nothing but 4c2. 1 plus 3 4, which is nothing but 3c2. This is the direct answer. 5c2 into 4c2 into 3c2. 5c2 into 4c2 into 3c2. Here ABC equivalent to K. K is a factor of 100, which is nothing but 100 by D. D is greater than or equivalent to 1. So ABCD is nothing but 2 square into 5 square. 2 plus 4 6, which is 5c3. Power is same, it is also 5c3. 5c3 into 5c3. 5c3 into 5c3. I hope the idea it is clear. Now see here. Next question. Find the number of integral solutions for the equation. Integral solutions for the equation. Concept. What is the previous question? Positive integral solution. Now it is an integral solution. So integral solutions is nothing but, integral solution is a combination of values and signs, because integers can also be negative. Integral solutions means one more case we have to do. Value we have to find it out, sign. Suppose we got a value 2, if I attach minus 2, I will also get a negative integer. Nothing it is there, sir. ABC is, it is nothing but 120. 120 it is nothing but 2 cube into 3 into 5. 2 cube into 3 into 5. First we will do the values. First we will do the values. Values it is nothing but 3 plus 3 6. 6 is 5c2. 1 plus 3 4, which is 3c2. 1 plus 3 4, which is 3c2. These are the values. Signs. Signs means 3 numbers product is positive. So 3 numbers can be positive, positive, positive. Positive, positive, positive. I got the answer 1. Negative, negative, positive. Negative into negative is positive. 3 signs can be arranged among themselves in 3 factorial. 2 negatives are there. So divided by 2 factorial. So these nothing but 1 plus 3, 4. So answer is nothing but a combination of values as well as the signs. 5c2 into 3c2 into 3c2 into 4. This is the answer. 5c2 into 3c2 into 3c2 into 4. I hope the idea it is clear. Again I am referring. What is the difference between previous question and this question? Previous question it is a positive integral solution. Now right, it is a integral solution. Suppose right, integral solution is nothing but it can take a negative integer, it can take a positive integer, it can take 0. 0 anyway it is not possible. 0 into anything it will be 0. So that means whatever the values that I got it, in that one if I put a sign, if I put a sign change, these also you will get. Negative into negative, positive, positive into positive, positive. Positive, 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 I got positive. So every value, all the 3 can be positive, all the 3, 2 can be negative, 1 can be positive. So total 3 cases. Minus, minus, plus, minus, plus, minus, plus, minus, minus. The values can be all this. 5c2, these nothing but the values, these nothing but the values, these nothing but the signs. Values and signs. I hope it is clear. Denominator is always, suppose if I say 2 is a factor of 4, 2 is a factor of 4. That means 4 when divided by 2, remainder 0. Denominator should always be a positive natural number. Factors comes for natural numbers. So denominator has to be greater than or equivalent to 1. Denominator has to be greater than or equivalent to 1. Because factors always comes in the natural number set. I hope this idea it is clear. Next one. ABCD. ABCD is nothing but 360. 360 it is nothing but 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. Now see here. First case number 1. Values we will do. If I do values, 3 plus 4, 7. 7 is nothing but 6C3. 6C3. 2 plus 4 is 6. 6 is nothing but 5C3. 1 plus 4 is 5. 5 is nothing but 4C3. 6C3 into 5C3 into 4C3. 6C3 into, I hope this is clear. Now 4 variables it should be. Case 2. Case 2 it is nothing but signs. Case 2 it is nothing but signs. Which all signs are possible? Plus, 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 which is nothing but one way. Negative, 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 negative. Even number of positives, even number of negative. These again one way. Negative, negative, positive, positive. Product is again positive. Out of 4 factorial, 2 are negative, 2 are positive, which is 6. So answer for this question is 6C3 into 5C3 into 4C3 into total cases it is nothing but 8. 6C3 into 5C3 into 4C3 into 8. I hope the idea it is clear. Everybody kindly reply. I hope integral solutions finding it is clear to you. Integral solutions finding. The idea it is clear to you. First is we have to find out the values. Next is we have to find out the signs. Next is we have to find out the signs. Suppose if the question is like this, 6C3 into 5C3 into 4C3 into 8. Suppose if the question is like this, ABC equivalent to minus 20 it is there. How many values ABC will take? Negative. These nothing but minus 2 square into 5 power 1. 2 square into 5 power 1. Case number 1. Case number 1. It is nothing but values. 2 plus 3 it is nothing but 5, which is 4C2. 1 plus 3 it is 4. 4 is nothing but 3C2. 3C2. Values we got. Signs we have to do. Product is negative. Negative means positive into negative. Positive into negative. 3 factorial divided by 2 factorial, which is nothing but 3. These nothing but negative, negative, negative. Negative into negative, positive, positive into negative, negative. So one way. So answer is nothing but 4C2 into 3C2 into 4. If the right hand side is negative, please make a note, sir. 4C2 into 3C2 into 4. Case number 1 is values. Case number 2 it is signs. Case number 2 it is nothing but signs. I hope the idea it is clear, right? Now, for example, suppose in how many ways can 120 be written as a product of 3 natural numbers? In how many ways can 120 be written as a product of 3 natural numbers? As a product of 3 natural numbers. Listen carefully, sir. As a product of 3 natural numbers. These is nothing but an unordered pair. These is nothing but an unordered pair. What do you mean by unordered pair? Order is not important. Order is not important. The way in which you write the product, it is not important. Example. Let me first take ordered pair. Ordered pair is, for example, if ABC is 12, example, 1 into 1 into 12. This is different from 12 into 1 into 1. 12 into 1 into 1. Both are different. One is A value is taking 1 and A value it is taking 12. But in unordered pair, 1 into 1 into 12. Reverse is also right. It is equivalent to 12 into 1 into 1. It is equivalent to 12 into 1 into 1. A comma B comma C is equivalent to C comma B comma A. Here a comma b comma c is not equivalent to c comma b comma a. Please make a note of it, sir. Ordered pair, order in which you write matters. Unordered pair, order in which you write does not matter. Ordered pair and an unordered pair. Ordered pair and an unordered pair. Now one by one we will solve. First one, it is 120. 120, it is nothing but 2 cube into 3 into 5. 2 cube into 3 into 5. First we will find out the ordered pair. First we will find out the ordered pair. It is written as product of 3 natural numbers. From ordered I will subtract, I will get unordered. Ordered pair, what will be the answer? So 3 plus 3, 6. 6 is nothing but 5c2. 1 plus 3, 4. 4 is nothing but 3c2. 1 plus 3, 4, which is nothing but 3c2. These is nothing but 5c2, it is 10. These is nothing but 3. These is nothing but 3. So 3, total ordered pair. Answer is nothing but 90. In that one, all variables are equal. All variables are equal. If all variables are equal, this will become a into b into c equivalent to 120. A cube equivalent to 120. 120 is not the cube. So this case can be eliminated, right? Two variables are equal. If two variables are equal, say a is equivalent to b, this will become abc is equivalent to 120. Which is nothing but a square into c is nothing but 120. A square into c is nothing but 120. Listen carefully, sir. A square into c. A square is a perfect square. A square is a perfect square. Which all perfect squares I can take out of factors? So n is nothing but 120. 120 is 2 square into 2 cube into 3 into 5. What are the perfect squares that are possible? Perfect square means power should be an even number. 2 power 0, 2 power 2, 3 power 0 and 5 power 0. So 2 into 1 into 1. Total it is 2. Perfect squares means a square is a perfect square, right? So power should be an even number including 0. 1 is a perfect square. 2 power 0, 2 power 2, 3 power 0, 5 power 0. So total 2 cases we got. 2 cases we got. 2 into 3. What is 2 into 3? Total 6 cases we will get. What is these 3 cases? A equivalent to b, b equivalent to c, c equivalent to a. Total 3. 2 into 3, it is nothing but 6. Out of 90 total, this is 0, this is 6. So 90 minus of 0 plus 6, which is nothing but 84. 84. What is this one? This is nothing but an unordered pair. Unordered pair, ABC and CBA are equal. 3 numbers can arrange among themselves in 3 factorial. 84 by 6, which is nothing but 14. 14 cases where all the 3 are unequal. 14 cases where all the 3 are unequal. What is these 6 cases? Let us see. In that one, any unordered pair is there? Let us see. First one, 1 into 1 into 120. Am I right? A is 1. It is next one. Next one, for example, 2 into 2 into 2 into 2 into 30. 2 into 2 into 30. 2 square it is 4, which is a perfect square. Any other cases are there? See here, 1 into 1 into 1, 1. So these are nothing but these 3 factorial by 2 factorial 3 cases, 3 factorial by 2 factorial 3 cases. This is completely 3 cases. Unordered means reverse is also same. Order does not matter in which you write. So this is one way and it is one way. So answer for this question is 14 cases where all the 3 are unequal and two cases where two variables are equal, another is unequal. Answer for this question is nothing but 16. What is this 16? 16 is nothing but an unordered pair. 16 is nothing but an unordered pair. What is the difference between ordered pair and an unordered pair? Unordered pair, the order in which you write does not matter. So 1 into 1 into 120, 120 into 1 into 1, 1 into 120 into 1, all that it is considered as one way. These also considered as one way. 1 plus 1, it is 2. Nothing I did. Again I am telling you step by step. Ordered pair, it is nothing but 3 plus 3, 6. 6 is 5C2. 5C2 into 3C2 into 3C2. Total 90 cases I got. All the variables are equal means A into A into A. A cube is 120. A cube 120 is not a perfect square. So these eliminated. Two variables are equal. A equivalent to B. So A square into C is 120. A square is a perfect square. Perfect square power should be an even number. So 2 power 0, 2 power 2, 3 power 0, 5 power 0. Total 2 cases I got. 2 cases where A is equivalent to B. 2 cases where B is equivalent to C. 2 cases where A is equivalent to C. 2 plus 2 plus 2, total 6. Out of 90, 0 and 6, 84. 3 numbers can be arranged among themselves in 3 factorial. 84 by 6 is 14. 14 cases where all are unequal, and out of these 6 cases, 1 into 1 into 120, 2 into 2 into 30. Order does not matter. This is one way and it is another way. So 14 plus 2. Answer is nothing but 16. Answer is nothing but 16. Again listen carefully. Again listen carefully. Suppose this is an examination question. In how many ways? In how many ways? 2310. In how many ways can 2310 be written as a product of 3 natural numbers? Unordered pair. In how many ways can 2310 can be written as a product of 3 natural numbers? Can be written as product of 3 natural numbers. Product of 3 natural numbers, which is nothing but an unordered pair. Let us go step by step. Once you understand ordered and unordered, it will be quite easy, sir. So 2310 is 2 into 2 11s are 22. So 2 5s are 10. These is 1155. These is nothing but 2 into 5 into 231. Am I right? These is nothing but 2 into 5 into 3 into 77. So these are nothing but 2 3 5 7 11. 2 3 5 7 11. These are the factors as a product of 3 natural numbers. First we will do ordered. ABC is nothing but 2 power 1 into 3 power 1 into 5 power 1 into 7 power 1 into 11 power 1. 11 power 1. Now see here. So total 1 plus 3, 4. 4 is nothing but 3C2 into 3C2 into 3C2 into 3C2 into 3C2. 3C2 is 3. 3 power 5, which is nothing but 243. Total ordered pair is nothing but 243. Case number 1. Case number 1. All the variables are equal. If all the variables are equal, if all the variables are equal, this will become a cube equivalent to 243. 243 is 343 is 7 cube. 243 is not a perfect cube. Case number 1 is not possible. Case number 2. Case number 2. Two variables are equal. If two variables are equal, these is nothing but, say A is equivalent to B. These is nothing but A square into C is nothing but 2 into 3 into 5 into 7 into 11. Power should be an even. Only one number I will get. Only one number I will get. What is that number? 1. So 1 into A equivalent to B, B equivalent to C, C equivalent to A. 1 into 3, 3. Case number 3. None of them are equal. None of the variables are equal. So none of the variables are equal. These is nothing but 243 minus 3, 240. Three numbers can arrange among themselves in 3 factorial. 240 by 6, which is nothing but 40. Here I will get 40. Here only one way it can be arranged, which is 1 into 1 into 2310. Order does not matter. So answer for this question is 41. The number of ways of writing the number as a product of 3 natural numbers in unordered pair is 41. Kindly reply in case if the logic is clear to you. If the logic is clear to you, kindly reply.